Okay, hello everyone. Welcome to Always Coding. This is our weekly developer Hacky Hour. If this is your first time joining, welcome to Hacky Hour. If you've been here in the past, welcome back. Hacky Hours are really intended for our community of developers to join us and ask questions, share what they're working on, and just have an overall interactive session around something we're presenting or computer vision in general. So at any point during this presentation, feel free to raise your hand, type your questions in the Q&A section, and we'll be sure to get right to it. So if you have attended Hacky Hour in the past, just know moving forward, this is going to be our new time for Hacky Hour at 10:30 a.m. PST every Thursday. We just changed the time to accommodate people in different time zones. So hopefully this time works for everyone. If you prefer a different time or if you know that there's a different time that works better for your teammates, just let us know and we can think of some other times as well. All right, so my name is Komal Devjani. I'm a developer advocate with alwaysAI, and I'm joined today by Laila Malani, who is also on the developer advocacy team. Welcome, Laila.
Hi, Komal. Thanks.
Hey. And today's focus is virtual green screens using semantic segmentation. So before we get started, Laila has a really cool demo to share with everyone today. But before she goes into that, I'm just going to show you how to quickly set up and run a simple semantic segmentation model on your local laptop. So let's get started. I'm going to share my screen here. So the number one thing you're going to do is go onto alwaysai.co. And if you haven't signed up already, make sure to sign up or register for an account. Once you've done that, you'll be navigated into your dashboard. And here you can train a model, create a project, check out some of our popular starter apps, and download the CLI. You can download the CLI using the instructions here, or what we're going to do today is just create a new project. And we're going to use a semantic segmentation template. And we can just call this Hacky Hour green screens. And let's just go ahead and create this project. Once we've done that, we're going to view our project. And here, as you can see, there has been a default semantic segmentation model added, and I'm totally fine with this. Let's just go ahead and run it as is. Before you do run it, you will need to download the CLI for your specific operating system. So I'm obviously using a Mac, so I would have just clicked this and followed the instructions to download the CLI. So what I want to do now is navigate into my terminal, and let's go into my demo directory. And what I want to do is just copy the first command here and paste this into my terminal and hit enter. And I want to, yes, proceed with download. Oh no. I think I have to maybe log in again. I did this yesterday and it logged me out immediately. Oh, so it says I'm already logged in.
Maybe, let's see, is it in the same directory? You might need to like delete the project file or the VN and try it again.
VNV?
Yeah, try deleting that. Oh, yeah.
Thanks. Okay, all right, let's try again.
I know.
I'm gonna download and let's see.
What is it? Is it,
That's so interesting. It worked like 5 minutes ago.
That's weird. Let's see. Is there like already a project with that?
I don't know. Maybe I'll delete the app as well.
Yeah. Yeah, it could be it. That's strange. I haven't seen that one before. Sometimes I get them if I delete my project on the dashboard and then try to use it again. Obviously, that's not going to work. You have to like start from scratch.
Directory not empty, rename. Semantic segmentation users.
Images, the images directory. Trying to rename the images directory from semantic segmentation to alwaysAI directory.
Oh, and we have a, do we have to download it? So we have a question here. Do we have to download it? You do have to download the CLI to get started. So yeah, Abby, I'm going to try to remove the images directory.
You could remove the whole thing. Yeah, just, yeah.
Let's see. All right. Fourth or fifth time is the charm.
Yes. It's good. It's always good. Yeah, that looks better.
Perfect.
Nice.
All right.
Yes.
Awesome. All right. So now we're just going to follow the rest of the instructions here, which is AI app install. And then, and I know you guys are writing your questions in. I'm sorry, I'm going to get to them in just a moment.
Well, the first one is, do we have to download it? Can we do it without it? If the question is regarding either the CLI or the app, you'll have to download them both to do the tutorial. But you can watch and follow along and then look at the recording later if you want to actually step through stuff. All the code will be online. But yeah, you do need alwaysAI, and you do need some sort of, we have the GitHub repo, or you can do what Komal's doing now with the semantic segmentation. You can pick and choose what you want to follow along with.
Yep. Yeah, and so, once this is ready, I just basically follow the steps right here. So AI app install, AI app start. And then what I want to do is just copy this link and paste it onto an empty browser. And as you can see, this is running a semantic segmentation model, and this is the specific model FCN, Alex, Net, Pascal, VOC. And the idea here is that semantic segmentation analyzes every single pixel within the input image, and it delineates between the background as well as the other objects that it's looking for. So it's identifying like the background as a separate label. So yeah, that's basically it for how you get started with your semantic segmentation app really quickly with alwaysAI. And now I'm going to hand it over to Lila to go over the virtual green screen.
Thanks. Yeah. And there's one more question. Will we send the recording? Yes, the recordings are always up on YouTube, and whenever Komal sends out the Hacky Hour announcement, you can, there's like a link to the old videos and stuff. So, barring any catastrophes on YouTube and stuff, you'll be able to watch it later. Okay, nice. So, yes, it's earlier than it usually is, so forgive me if my coffee hasn't totally activated my brain, but I like this. It'll be good. We'll start the day with a Hacky Hour. So as Komal mentioned, we're doing semantic segmentation and virtual green screens, and she already went over a little bit what semantic segmentation is, but image classification classifies an entire image with a label. Object detection will give you a region of an image that's assigned to a label. Semantic segmentation assigns a label to every pixel. So that's a pretty cool thing to do. And today we're going to use a semantic segmentation model to do a virtual green screen. Are people familiar with virtual green screens or green screens in general and what that means? I don't know if you can like raise your hand or type in the chat if you are or not.
Actually, we do have a couple of raised hands, so let's see.
Nice. Yeah. So for people who don't, the idea is, or if anyone wants to describe what a green screen is now, please take it away. Does Fleming, would you like to?
Yeah, Fleming, you can speak. You can unmute yourself if you'd like.
No, I'm not necessarily interested in.
Gotcha. No, that's fine.
But as far as I understand, I do a lot of work with regular green screens, and I'm just interested in seeing how I can apply AI to it.
Cool. Yeah, well, this is a pretty rudimentary one, I will admit, if you're working with professional green screens, but it's nice that you can use this technology to make your own, just sitting at your own computer. So for people who aren't familiar with green screens, the idea behind a green screen is that you have a green backdrop and then a person in front of it, and anything that is green will be replaced out with, like a CGI background or some other background. They use it for news anchors or like visual effects. And so that is using like a color key. So rather than a label key, which we're going to get into with the semantic segmentation, although the labels are mapped to colors, that's the whole point. But yeah, that's the idea behind it, is that you have one kind of coded thing that's green. In this case, maybe it will be person or background, and you're going to target those colors or labels and swap them out for things. So we're all using Zoom now. I could have used my own virtual background with Zoom, which you guys probably have had fun with, you know, in work meetings or school meetings. But it's the same concept. So we're going to build our own, and you'll notice the model that Como used was fairly rough. And, you know, I'm not an expert with semantic segmentation. I assume that's the kernel size making like the boundaries for what label regions are. So we have some semantic segmentation models up on alwaysAI. I'm going to show you where those are, and I'm going to show you some output I had from tinkering with different ones. You're going to get a different level of granularity. But the one that worked best for me with this green screen and identifying people was that chunky semantic segmentation model. And then I was like, well, this looks silly. It doesn't look very good. How can we smooth it out? So the first app is a virtual green screen. Then we have like a second piece of code where I'll show some like numpy manipulations we did kind of in the interim. And then the last one uses a function that Eric wrote and is now in the EdgeIQ library for actually blurring. Well, we blurred the edges later, but then he did like a function to kind of smush a foreground and a background with those kind of blurred edges to give it a little bit more clean of a look. And so obviously, if you wanted a really nice crisp model that gave you nice edges, you'd have to train your own, and we don't do that yet with alwaysAI. But this is a cool way to use an existing model, existing tools, and prototype really quickly to get a workable solution in your own virtual green screen. So that was a lot. Let's see, we have some links for you guys too. Let's give you, this is the virtual green screen repo on GitHub. This is the one that will be used to smooth the edges. And then at the end, there's some other blogs and repos up that you can check out that Eric has written. That one is a pedestrian semantic segmentation, and it uses the label map to remove items from the image, which is also a neat functionality. And I don't know if you guys are super familiar with semantic segmentation in general, but we mentioned that it's assigning specific labels to every pixel. And does anyone want to offer some ideas about why that would be really useful in other applications, maybe in the real world or maybe in prototypes? You can type them in the chat if you feel like it, while I paste in a couple more links. And if not, then I will offer some opinions.
So actually, you know, before we get into that, Lila, apologies, but we have a question here about what is alwaysAI, and let's just pause for a moment. Let's just pause for a moment and answer that question, because I think
that one definitely takes precedence.
Yeah. So alwaysAI is a platform that enables developers to really quickly train computer vision models, develop computer vision applications, and deploy these applications out onto the edge. So this can be done without, like, you don't need to use cloud for your inferencing. You can simply use your edge device to collect data about, collect visual data about anything out in the environment. So hopefully that was helpful. And alwaysAI has various different tutorials and like events that we do to help, you know, new users or new developers learn about how to use this technology and how to build various different applications. And today's application happens to be a virtual green screen. So Abis, I hope that was helpful for your question.
Yeah, and we also have our Discord channel. If you ever want some more info, or if you ever want to chat computer vision, all the users on there are really friendly and helpful, and maybe that's another good resource. I'll find the link.
I have it. I'll send it.
Okay, nice. For some reason, I always have a hard time finding the link, like just out in my stuff. Okay, so let's get started. Did anyone want to offer a possible cool use case for semantic segmentation, or should I just do it?
Yeah, does anyone have any ideas of what we might be able to do with semantic segmentation? You can raise your hand at any point
And like why is that granularity with individual pixel labels so important sometimes, and like a bounding box or just like a general image label not going to cut it?
Let's see, we have a note here. Okay, so there's also another question.
Yeah. Sorry if you missed this. Como did a nice little brief intro, but semantic segmentation, and she did a little demo. You can watch it back later. I'm going to be doing some more demos. It will assign a label to every pixel in the image. So image classification assigns a label to an image in general. Like if there's a dog in the image, it says dog. If you're using object detection and you're trying to do dogs and cats, it'll be like, oh, there's a cat in this general region of the image, and a dog in this general region, and a cat over here. If you're doing semantic segmentation, it'll be like, this pixel belongs to a cat, or this pixel is a cat pixel, this pixel is a cat pixel, this pixel is not a cat pixel. So, so you can detect boundaries between things very easily. You know, this is the cat, this is not the cat, that's the boundary with the cat. That's like my leading question. Why are some applications really dependent on knowing specific boundaries between a label of interest and some other label? That was
we have a suggestion here that scene understanding can be an application of semantic segmentation.
What was it? Sorry?
Scene understanding.
Scene understanding? Like, yeah, with your eyes?
Yeah.
Or seeing like the scenery.
You're welcome to, he said like for autonomous driving. That's
like for autonomous driving, yes, where you really need to know the curves of the road, where objects are for sure. Maybe another one would be like cancerous cells versus non-cancerous cells. I mean, that's pretty advanced. I don't know how many applications are actually like robotics or something. Anything I think with robotics that you want really fine-grained like detection of things. But yes, that's what I was driving at. No pun intended. Yeah.
And we have another question here that says, can we use REPL.it or other resources like that instead of the CLI? And I don't think you can. You have to use the alwaysAI CLI to use all
Yes. Yeah, I don't know. I actually am not familiar. If anyone from alwaysAI is on and under, has any extra, they can definitely jump in. But yeah, I'm alwaysAI, you can use our dashboard to create projects, but you really need to use the CLI to run your models, start your apps. You can add, remove models. It's a pretty simple CLI, I would say. Like there's a few core commands, you can get a lot done. And then there's EdgeIQ, which is the API for Python. So those are the two big components of alwaysAI. I would say they're pretty easy to use and just jump into. But if you download alwaysAI, you have the CLI, it's there, and you pretty much have to use it to run these applications. We doing okay? Other questions, or?
Yeah, we're doing great.
We jump in? Okay, nice. So this is the alwaysAI GitHub. Lots of cool stuff on here. We really encourage you guys to come check it out. There's lots of cool projects. Here's the darts one that Eric did a couple weeks ago. This time we're going to be using these two, virtual green screen and smooth semantic segmentation. So what you can do is clone it or download it. I've already done that locally. And so first we'll just demo the virtual green screen app. And then I cheated. I already configured and installed my stuff because I've been messing around with my projects and I wanted to make sure it worked. So what you do is you can go into a repository where you want the new Hacky Hour stuff downloaded. What you can do is do git clone, and then you would copy paste this URL. Oh, yes, yeah. You guys can see my terminal, right? I shared the whole screen. Okay.
Yeah, we can see your terminal.
Okay, because that's definitely something I'd forget to do first thing in the morning.
Likewise.
So yeah, you would git clone this. It would clone it. It would say virtual green screen. You would CD into virtual green screen, which I'm already in because I already cloned it. And then you would do AI app configure. It will prompt you to make a new project. You can just give it a name. So it's kind of the reverse of what Como did from the dashboard. It's the other way you can configure a project. So you just do AI app configure, no project string, and then you do install, and that will build the virtual environment. And you can see I've got that already. So now we just do AI app start and localhost. Okay, so now you can see I'm in the stream and behind me is probably like the Bahamas or something. And it is pretty granular. There's these big chunky pixels. However, if you were really desperate, if you had like a horrible background and you had like a bunch of roommates or your apartment was really messy and you had to do some sort of stream, then this would be a way for you to just kind of like get rid of all that, maybe just blur your background. So there's a couple things we can do. We can also blur the background, and I'll show the code that does that. I did also want to show kind of like how we interact with the semantic segmentation tools and the EdgeIQ library. So I'm trying to decide if the best way to do it is to step through the app first. And I think instead what we'll do is we'll play around with some semantic segmentation stuff first. So real quick, I have this intermediate piece of code. I can put it up on Discord later. Really all it is, and I'll show it, it's a basic kind of starter app. Well, it was the virtual green screen, and then I've commented out a bunch of stuff so that it's really just like that first app that Como ran, except it uses the streamer. And so this one, you can see is that there's that mask. So I'm in a color. You can see like this is red. This is some sort of thing. This is some sort of thing. What are those things? We don't know. And then everything else is this like just no color. That's probably the background, I would assume. So one cool thing you can do is now that we've built the virtual environment, that has pip installed all the required libraries, including EdgeIQ, which is how, if you've used our apps in the past, you create an object detection object, a classification object. Now we're doing a semantic segmentation object, and that I will show you here. So first we import EdgeIQ. There's a whole bunch of other stuff that we need. And this is another, if you guys aren't familiar with OpenCV, CB2 is the library. You can always add this to any app.py in alwaysAI, and we're already installing all of that library. So you can always use OpenCV with alwaysAI, and some of our functions I'll show that we've kind of wrapped there, so they're a little bit easier to use, I think. So here, what we do is we're creating a semantic segmentation object from the model ID. And right now I've set it up using this config file, which we'll go over a little bit later, but suffice it to say, it's an alwaysAI model. It's AlexNet that Como showed, and we can look at that later on the alwaysAI model page. But then we load the engine. That's an important step. And then we start the streamer, and here we get the results from running the semantic segmentation model on the image frame. And
AB has a question?
Yeah.
Hey, AB, you can unmute.
Yeah, hi Laila. Nice. Back to it's like old memories of this app. I just wanted to ask this question. I'm not not done much on semantic segmentation using AI models and all, but done a little bit of in OpenCV. The question what I had is, does this app would work better in case you had a plain background? Like for example, you were sitting. You have a wall on the left, on your right side, right? So if your camera was facing and you were sitting just, and there was nothing behind, like there's a lot of things behind your behind you, right? So there's a chair there. There's, I think, something like a triangle-shaped text cloth there, and there's a monitor there. So there's a lot of varied backgrounds, right? So if you
Right.
had a what is like plain background, and then you run this app, will it be give better results?
That's a good question. We can try it out. I can like move.
Sorry, yeah, okay.
Yeah, I wondered. I think it would depend on the model itself, because what the app ends up doing is pulling out a label of interest.
So basically, it will have a label of the person, and then
right, yeah. But if the background was really like, if the background was such that it was very similar to how the model was trained, maybe, then I would think that it would hold that person better. You know what I mean? And then, so it could be, but I'm not sure if in this particular case that would happen, but I can definitely see the logic behind it. And there also, when I was playing around with this the first time, I tried different models, and I tried different like blur ratios and stuff. And I did not actually try, hey, what happens if I just stand behind a plain wall? But that would have been pretty like, intuitive solution. So that's a good point. And maybe we can just try that out at the end, standing in front of a plain wall, or maybe like a darker color or a lighter color would work better. Because I definitely think you're right. If the model had a better time detecting those boundaries, because maybe it is getting a little like chaotic with it. It thinks this is like a TV monitor. We'll see when we do the labeling.
Did you filter out the labels as well? Did you filter out the label? Okay.
Yeah, we're gonna dig into that a little bit. And
no, that's why I did not want to spoiler
it's
there,
good.
but
It's the teaser, yeah.
Okay.
Yeah.
No, okay. Because I did something like I was doing this, but not with AI, but using OpenCV masking. You can do create mask as well and still blur the background. But what you do is you give a piece of 1 minute background, and you tell that this is the background, and then you create a mask, and then you just have a mask of the color or something, and then you mask that recording you on that thing. So it's something like that. It looks like you are an invisible man. So
yeah, that's cool. Yeah, that would be neat. Yeah, maybe Eric's app, he used like past frames to fill in like the current frame
exactly
to remove people from it. Kind of
yes. Yeah, okay. Oh, sorry. Yeah, but this
great.
was my question. I was so much curious. I was waiting. I thought you might tell that, but I wanted to ask this question. So
no, it's good. Please always ask, always jump in.
Always ask questions in alwaysAI Hacky Hour.
In alwaysCoding Hacky Hour. Yeah,
exactly. Always coding, always asking, always.
Yes.
All right.
Cool.
We actually have a couple of questions, and I think Lila, I might have to ask you to help debug someone having a failed attempt at trying to download the CLI.
Oh, okay. What is it?
And it's his name is Abis Zafar. So Abis, if you're comfortable with like speaking out loud, I'm gonna unmute you if that's okay. Hey, Abis. I think you're on unmute now, so you should be able to speak.
Be a microphone issue.
Yeah. Okay.
Yeah, my mic wasn't plugged in.
Oh, nice.
Hey.
Hello. So I was downloading the CLI for Windows in the alwaysAI, and then I got the error that CLI installation failed.
Okay.
Should I retry or?
Yeah, let's see. I actually think someone on Discord might have done this on Windows. Maybe not. Yeah, have you ever installed alwaysAI before, or is this the first time?
It's my first time.
Okay, let's see. Okay. And let's see, AB had this issue at some point. I'm not sure if this is right. Did it just say installation failed? Did it have an error printed in that screen?
It did.
Did it say permission denied?
No.
It says CI installation failed. This file may have become corrupted during the download. Installation may succeed on retry.
I would retry.
Yeah.
I would maybe re-download it. It shouldn't be. I mean, it's a little strange. It could maybe if it's like a really slow download or something. I'm not super
Yeah,
familiar with
it's been doing this for the past half an hour.
that. Okay, I'm sorry. Have you tried it a couple times then?
No, this
Just one?
one try was half an hour around.
I see. Yeah, and actually, I have downloaded it on Windows, and it took a lot longer than it did on my Mac. Okay, I'm sorry about that. I would get rid of that and re-download it and reinstall, and then let's have you go on Discord too. We can definitely do a one-on-one or troubleshoot with you more like in person if it's still having trouble. Is that okay?
Yeah, that's okay. Thank
Okay,
you.
sorry about
And
that.
it seems, yeah, I'm sorry, Abbas, about the issue, but it seems David Dodds had the same issue. So maybe David, like, if you could type out in the chat to see like what helped you resolve that issue, because I know you're actively working on it now.
Okay.
That would be super helpful.
That'd
Thanks,
be-
Abbas. Sorry.
Okay. You're welcome.
All right, we'll see you on Discord.
Yeah.
And then we have a couple more questions, Lila.
Yeah.
So the first one is, can you make the background variable background? Like Zoom has an experimental feature of your PowerPoint as your background.
Yeah, I mean, okay, so you can it's just an image the way I did it. Could probably get fancy and do like a well, I don't know. I wouldn't want to promise you could like actually stream a video. I feel like you might have to do like on a loop or something to keep refreshing it, or pop a frame, read a frame in. PowerPoints are just slides, images, so I did see that in school where people would change their background to be their presentation slides so that everyone matched. Very, very cute. But yeah, if the way this one works, we can step through it instead. First is that I have some possible background images in a folder that that I've just saved. So this is the virtual green screen. These are the images, and I included them, I think, in the GitHub repo. Yeah. So you could make a PowerPoint slide. You'd have to save it as a JPEG or PNG, which I believe you can do. And tinker around with it. I'd love to see if somebody else could make a different type of app. This is just a pretty rudimentary, swap out your background with any kind of static image. So what you can do is in this config file, which is here, you specify which one you want. So I wanted the beach pick, but you could pick mountain library. So if you had a JPEG saved of your PowerPoint, then you just stick it in this folder and change the config to be, presentation JPEG, and then it would be how your PowerPoint looked. Probably not as sophisticated as Zoom. I'm gonna say that's a safe bet, but it would be a way to do that. It's a good question.
Amazing.
Any other questions?
We did have one, but actually Eric already answered it.
Oh, nice. Nice. So I'm torn. We could step through the virtual green screen app, or we could dig into the semantic segmentation rudimentary stuff. I think I'll do that, because that way you guys can always dig through the app yourselves later. We still have a fair amount of time. So this is this code I called intermediate code. It was after the virtual green screen, before the smoothing segmentation edges. I can put it on Discord or something later, but it's pretty much the same, just with a couple minor tweaks. And then I commented it all out, and I just used the regular map. But okay, so we instantiated a semantic segmentation object. We loaded the engine. We started up the streamer. Then we read in a frame. And now we get the results back. So that's where we left off. We have these results, and then we do something that AB alluded to, which is building a mask. And then we blend the images. This is stuff that's all in that starter app that Komal showed. And then we send it out to the streamer. So it's a little weird, like, what is a mask? Why do you blend it? the fun thing is you don't really need to know if you're using alwaysAI. You can just jump right in and start tinkering around. We have some really good documentation. Here's the semantic segmentation documentation. I lost my chat, but I'll post it in the chat. Well, let's see. I can probably get it back. Chat, Q&A, chat. Okay, here is the semantic segmentation. And then here are some tools that we're going to use. So the semantic segmentation, you can see we get this results. The results here is what you get when you call segment frame. Oh, where did it go? Segment image. And it returns semantic segmentation results. So we can see when we get that, it's just a class map and how long it took to make that inference. So it's like, what is the class map? If you're using alwaysAI, it's cool that everything is containerized, and that's great. But sometimes if you're like me, you want to open up your Python interpreter and kind of like mess around with stuff, you know, if you're working with bounding boxes. So this is what I thought was really useful. Where are we? All right, we're in intermediate. We have this virtual environment. What you can do is you can say source vn bin activate. And now you can see we have this little vn pop up here. That means that we're in the virtual environment. And that means we have all the libraries and tools that alwaysAI installed when it built the virtual environment, including OpenCV and EdgeIQ, lots of good stuff, and all of the regular Python stuff. So it's just like what your app will be seeing when you run the app. And now I've created this little commands file. It's my little cheat sheet. But it's pretty much all the commands that are in the apps themselves. So here, what we're going to do, first thing is import edge IQ. And if you did this, oh, great. It's not, oh, wait, did I activate it? I did, didn't I? That's weird. Import, oh, duh. You need to start Python 3. All right, now we're in our Python interpreter and we've activated our virtual environment. So now we can do import edge IQ. And if you did that without doing the Python environment, it'd be like, I don't know what you're talking about. I can't import anything. And also if you did it outside of the virtual environment, it'd be like, what's edge IQ? I don't know what you're talking about. Because it hadn't installed it, we didn't do it in our virtual environment. Is that okay? Do we have any burning questions?
Yeah, so this is actually an interesting question. Is there a type of dictionary for all the commands available on alwaysAI?
Well, you can do AAI. It's not really a dictionary, but it will give you all the commands. Oh, did you mean like the Edge IQ library or the CLI commands?
CLI commands.
The CLI commands. So if you just do AAI, or even like AI train or AI models, it'll be like, that's not right. Did you mean this? And it will give you some helpful suggestions. And then on our documentation, there's
Can you like type in AI help? I wonder if that works.
Yeah, maybe. I haven't actually tried that one. No. Well, it does the same thing. It does. It just says, app configure. So it's kind of a tree structure. AAI is always the first thing. That's how you're using alwaysAI. And then if you do app configure, app deploy, app install, these are all your app commands, model commands. These are all your training commands. And so if you type in AAI data set train, then it will give you some more specific flags for the training command because you didn't offer enough. So you can kind of, I think this is a good way to do it because it doesn't give you tons of stuff. It gives you like hints as you go along. That way you don't just get like a huge screen full of tons of commands. But is that kind of what you're looking for?
Yeah, I think so. And I'm going to send a link to all the docs as well. So
yeah.
you can look at that.
there's more details, like for the model training, there's a set of commands and descriptions about what they do, all the flags, which are required, which are not. And same thing, it's kind of peppered in, but, and then of course, we have the Edge IQ library as well.
Yep.
Is that, we're good for questions for now, or?
Yep.
Cool. Okay, so we're in our Python interpreter. Import so these are some, like, you know, if you work with our stuff, if you work with computer vision or Python in general, probably use OpenCV, NumPy. I'm also going to import sys, because when we look at these NumPy arrays, they're huge, and it won't show you all of them, and I want you guys to be able to see the labels and whatnot. Okay, so if you were like me when I first started out, you would just rerun the app. You would tinker something, rerun the app, tinker something, rerun the app. And that works great, especially with the streamer, because it's still a pain to do the CV2 im show. I don't know why, but I can never get it to work properly. And even if it pops up, then I have to close everything to get it to go away. And I know about the wait key and destroy all windows. So I don't know why it doesn't like me. But so this NP set options will give you the whole list of the NumPy arrays. I can put that up. That's not in the general code. It's just something I Googled. Okay, so now we're doing the semantic segmentation. We're going to instantiate the semantic segmentation object and load the engine. And then I just took a screenshot from running the AlexNet earlier, and I saved it as output PNG. This is going to get around our needing to create a frame, the streamer, and read a frame in. So we've kind of skipped all this, and we're just popping down to here. Okay, so then, did we already get the results? No, we didn't get the results. Now we're going to get the results. Okay, so we can see dot duration. That was, you know, it took 0.16, blah, blah, blah. I assume that's seconds, is it? Yeah. And then we can do dot class map and see what that looks like. Okay, so we're seeing a bunch of zeros, zeros, some 11s. Like, what are those? And then we can do label map. Okay, now we see what those are. 0 must be background. And we can even do, what is it? I always forget. This is going to be the actual, I should have called them something more intuitive, because I always end up calling them the wrong thing, but we'll just try it. Semantic. Yeah, okay. So, and we'll do, wait, it was 11. What's 11? Oops. I always mistype labels. In model training, it's a nightmare. Semantic segmentation results, labels. How did that work? What is it? Am I just doing the wrong one? Segmentation results. This one worked. Oh, yeah. See, I told you, I should have called them like, oh my gosh.
You don't say labels twice, right?
No, I don't think so. Semantic segmentation. Oh, thank you, Como. Okay, it's a dining table. Okay, so something looked like a dining table. Yes, background, 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 background. Oh,
Dining table.
where's that? Okay, now it's background. Okay, I wanted you guys to see all the labels, but there is a downside to that. A lot of stuff is background. You can just scroll. person. That looks like something we wanted. Okay, anyways. So you can see the label map, you can see the labels, and then you can see that each label was mapped to the class map, so the 0th index background map to all the pixels that we're saying this is the background. So these are all the pixels that are labeled person. That's kind of just fun. And let's see. Okay, so this one. Now we're creating a class map of all zeros that is the same shape as the class map shape. And the as type int converts it from a float or double, whatever it's called in Python. Let's try that out. That's just in the virtual green screen code. So I just want to run through how you can open up a terminal, tinker around with this stuff, and see what you're actually working with. Because when I started looking at this stuff, and it's still like numpy arrays, my brain kind of rejects them. I don't really, indexing and stuff. It's still kind of like magic to me. But this is a way you can kind of get your hands dirty. Okay, so this is all zeros, and then here we have this labels to mask. It's in the config file. But, and you could tinker around with it. Is the config file still here? Yes. So person, but you could also do TV monitor. Oops. If you noticed when you printed out those labels, that like, oh, it's getting confused. It thinks this is a TV monitor. Let's just, or maybe like, it's cutting into my face a little. Maybe I want to expand the area around me to include chairs, or if chairs are labeled as TV monitors, okay, I'll do that too. And obviously you could always train a better model, but this is a way to kind of hack a better app with the model that you have for the situation that you have. Not that the model's bad, but maybe it just isn't suiting your needs. Okay, so sorry if I'm getting distracted. Okay, so we have these labels to mask. So we're going to iterate through all the labels to mask, which in this case is just one. And then we're going to kind of like toggle on, instead of a 0, we're going to pull out the labels that were of interest. So the ones that we actually want to keep. Let's see what that looks like. Right. Labels to mask. Right. Silly me. Forgot this part. Okay. So then we can do, let's see what that looks like. Still a lot of zeros because we're not interested in quite a bit. And I'm worried I'm gonna like overshoot. Okay, 15. What is 15? Is that the right one?
Yeah, it was semantic segmentation.
Thank you. It's person. Okay, so that makes sense. We want to pull out the person. Those are the ones that are now person. Everything else is zeros. Okay, so now we can also do image.shape, label, shape. All right, so this shape is giving you the shape, the width, the height. If there's a third one, then it's the number of RGB or BGR. It's RGB, but in alwaysAI, just so you know, it's BGR, whatever is backwards. So if you ever get funny colors, you have to swap the first and the last.
Yeah, I think AB has a question, Lila.
Yeah.
Hey, AB.
Thanks, Komal. I had a small suggestion. So
Yeah.
I think you ran some bunch of commands. Okay, so guys who might be new, I think it would be better if you do like a cv.imshow of what you read, so that they have an idea what's going on from the input image. I think.
Yeah. The reason why we didn't was because then I have a hard time getting out of it without bringing down the virtual environment and the Python interpreter. I've tried like hitting shift and
Okay,
hitting
okay,
control
okay,
C.
okay,
Yes, I
okay,
know. So
okay.
I know, and that was one of the reasons why I wanted to even do this, and I did try to do CV2 show, and that's a really good suggestion, and thank you. And I can do it maybe at the end,
At the end,
and,
yeah, of course, yeah. No,
and then we'll just call it a day on the interpreter, because then you have to
oh,
re-import everything. But
yes.
yeah, no,
Oh,
that's a
okay.
very good suggestion. Yeah, to just see what the mask looks like.
Yeah.
And
Okay.
that's a good suggestion for everyone else. When you do this your own, so what AB is suggesting is that you would do cv2.imshow, then you do like image window, well, probably like window, and then you would do image, and then you usually have to do wait key. 0 is usually what people do. Sometimes you can actually put a specific key in, and then you can do cv2. I think that looks right. And what that will do is CV2 will pop up an image that you want. And we will do this at the end to show one. But that's a really good suggestion because when you, all of these are numpy arrays. And so that's what's sent to the streamer. And you should be able to use that as an image. And then you can see, what have I done? What have I just done to my image? What does it look like? So yeah, very good suggestion there. It's just a pain. I haven't figured out how to do imshow without wait key, and then you have to force quit Python. It's probably like my own thing, but I don't know how to get around that. So we'll just save that to the very end. Okay, so the other thing you can do, instead of like doing this to figure out what 15 is, you can say, what is this? And it will give you, okay, it's 15 if I wanted to know which one it is. And then you can use that to index into, or to find which indices in the numpy array are they correspond to the label that you're interested in. Okay, so I'm sorry, I'm jumping around a little. I do want to kind of show what AB was talking about when he was saying like, what are those different things do? So this is kind of what it will look like. See person, well, you can't see, person was white, background was black. And so when you do those masks with white and black, and you, there's some blurring that's going on here, which I didn't do in those command line interpreters. This is kind of what it will look like. You can just do this in the app itself. You don't have to do the imshow. And that's kind of a nice thing. If you're using it with the streamer, you can just send the stream to the frame and just tinker around with it. And because if you're developing on your development machine, your Mac, your Linux, your PC, then you don't have to rebuild everything. You can just do AAF start. And so it's not so painful. I just like having the option to do the command line interpreter. Okay, so these were different levels of blurring and the overlay, which I will show the overlay in a minute. But you can just see this was 0.65, and then this was blurring a little bit more. This was less of a blur and less of an overlay. Okay, so this was just using person and chair. So you can see that I got a little bit more of the chair behind me. This was using a different model. This is the ENet model, and it had a really hard time finding my face, but you can see that the granularity is much finer than in this model. So that's why it's like, oh, I really would like the granularity of this model, but it just was not, just wasn't picking up the face. It wasn't close enough. This might be a case where AB said, try, maybe there would be some post-model steps or pre-model steps that could get this to work better. I'm not sure, a different background, closer. Maybe you could like pull a face out with a face detector first. I have no idea. But I just thought it was interesting. And this was the ResNet, FCN ResNet 18, blah, blah, blah. That was a little weird. It just got this very like sliver of a face. This is AlexNet Cityscapes SD with person. And so I think it's either this one or I think it's, or this one. I can never remember which one we chose, but you can see now it's a little bit better. Yeah. So any questions that we want to stop for now or keep going?
Yeah, just a couple of comments. Like AB said, nice testing. I love it.
Thanks.
And Steve also actually posted that, you know, if you want to try out different semantic segmentation applications with alwaysAI, you can enter AAI get starter apps
Yes.
in the CLI. And there's two applications, semantic segmentation cityscape, and that shows autonomous driving. And the other example is semantic segmentation VOC, which shows you how to do object detection using semantic segmentation. So
yes.
give that a go.
And the code that I was showing in this is really, if you do that semantic segmentation, I think it's the one that has the camera, whichever one that was, not the one that does the images. It's pretty much, this is the code that's in it. So that would be a good starting point. And then you could just step through and see what it's doing and check it out.
Oh, so there's a question here. Is the poor performance a model training problem?
I think semantic segmentation is just a heavier model, and it takes, or poor performance. Like, yeah. I mean, poor is like a relative term. Maybe for my use cases it's poor, but maybe that wasn't its intended use. You know, maybe I need to train it for my specific use. Maybe the people were supposed to be farther away, or like AB said, a different background. So, I mean, it could very well be a poor model for what I wanted to do. Not to say that the people who made the model did a bad job. But in terms of like what goes into training semantic segmentation models, I am out of my depth with that. It's not my area that I know a lot about. So maybe, I mean, if anyone else has opinions to offer live, then we definitely should. Otherwise, you know, on Discord, we can chat about it more. Yeah.
Yeah, AB mentioned it's based on conditions, data set, and where it's run. It has a lot of factors.
Yeah.
How can you improve the performance to get it around 20 milliseconds inference?
Inference time. I mean, I would think that would have to be like an accelerator or hardware at this point. I don't know, you know, if Steve's on and he wants to say something.
He actually did raise his hand here. Hey, Steve.
Hey, sorry, I had to push the unmute button. I was having a good conversation with myself on that. No, semantic segmentation is very heavyweight. So you've shown some like AlexNet, which is a fully convolutional neural network, which means what it does is actually goes in and as you said earlier, Lila, it's going into each pixel and identifying it with a class ID. And so one, you know, it's just heavyweight. So it's really throwing hardware at this one. You know, that's really one of the sweet spots of a NVIDIA system and so forth. And again, in the starter apps, we have a NVIDIA autonomous vehicle with semantic segmentation application, which shows you how to run that in if you have a NVIDIA hardware, a Jetson system and so forth. But that's the key on it, that it's pretty heavyweight model. What I would say is it was started at Berkeley for those type, and they're called fully convolutional networks on that. And then there has been some performance improvement that's come around with some of the different architectures out there. So, and I've forgotten what the name of the one we have in our, the Cityscape one based off of it is probably the fastest one out there and most accurate. So
Cool.
And I've forgotten what that one was, but it's been a while since I worked with Samantha.
Yeah, there's you can always go on our models page and check out the semantic segmentation models, and they'll have inference times with them. You can see they're pretty big.
So yeah, it's ENet. Thanks for bringing that up. That's the architecture that's really one of the more advanced architectures. There's a lot of work in universities. You should go check out their sites. And
yeah, and you can see ENet was the one that was super granular.
Yeah.
And I think it was just my background and maybe like lighting and stuff for this use case, the virtual green screen, it just wasn't working well, but you could tell it definitely got that fine grain boundary much better.
Yeah.
than the others.
The eNet we have is trained on Cityscape. So it's designed for, and Cityscape, for those who don't know, is just a data set where people drive around in cities. And so you can figure out what that is all about. That's about the autonomous vehicle. The other thing that semantic segmentation is most convolutional neural networks are designed to, detect something and ignore background. Semantic segmentation has a category called background that tries to find background. So especially in something like Cityscape, which is important for cars because you want to know where objects are and so forth when you're driving around. But you hit the other use cases that are big on these. Medical, for analyzing x-rays, and then they also would use it for structural analysis in products or bridges and things like
That's
that.
a very
So
good one.
anyway, I've said enough. You were right.
No,
It's
wonderful.
all about hardware.
Thanks, Steve.
Sure.
Thank you,
Yeah,
Steve.
I know we're kind of running short. I do want to do one quick thing if we have time for it and people are up for it.
One more question before we do the final things. So can you use a video as the background? So same thing, right? Like instead of the slide.
Yeah, that is what I was wondering. Let's see. So the way I did it was you have to take a frame and you're replacing pixels in that frame with other pixels in a different frame. So there's two frames. So technically, all videos are frames at the end of the day. You can read them in, pop off a thing. It might get into like some threading issues if you were doing two streamers. I know that you can only have one instance of a streamer, or at least that was the case on Linux. So you might have to do something else, read it in a different way. I mean, I can see ways to do it. If you were doing it in this application, I think you'd have to read in a different video file, pop in a frame, and do like instead of using a static frame for the background, you'd have to new frame, and your current video frame, and you'd be splicing them together the way this app does. But you could also do it a different way with different applications, like keep one video stream going and like, if it's like a web app, like statically, like just like, and then overlay like a component on top of it, but that's getting into like a different area. So it is possible. Zoom does it, but this is a lighter application that we made like, on the fly sort of thing. So it would just take a little bit more configuring, a little bit more detail. Maybe some issues would pop up. But you could, yeah, I'm pretty sure.
Yeah, and Lila, I have a really positive news for you actually as well, that Abbas is able to get CLI working.
Yay! I'm so
All of
glad.
you were wondering.
That's good. I was, yeah, no, that's good. Yeah. I know some, downloads, installs. Once you're up and running though, I think that's,
Yeah.
yeah. So let's do real quick.
One more thing. Yeah.
And then I can answer it as it runs even if there's more. Mac localhost. Okay, so now you can see the edges are smoother. And now that we're at the end of our demo, it's kind of like a cliffhanger is how that happened. Suffice it to say, there's some blurring there. We use this dilation that it's hard for me to like articulate in a short amount of time. You can read a little bit more about it, but the idea is that we made the whole background zeros, and made them black. The label map for everything is now black instead of that multicolored label map, which you can see here. So you can print out the label map. Where is it? Build legend. That's what it was. And it was right there. Yeah, build legend. So sorry, I'm jumping back. Please ask on Discord if you want any more like pointers and stuff. All the code, you can always find it up on those GitHub repos. But the idea is that we're only making the person white. Then we are building our mask from the class map. And then we're dilating in like a cross section certain pixels, which kind of give it that like halo sort of effect. And then blur the background mask with that with a certain blur level, it's set in the configuration file. The main thing is this function, which Eric wrote for this purpose and then put it in EdgeIQ. It takes a background and a foreground, and then that mask you built with the white and the black that shows the like delineations of person with background with the kind of like blurred edges, and it will splice the actual original videos in so that you see that instead of black and white, you see tropical backgrounds and my face. So that's a little bit, sorry that we left the kind of like more fancy stuff for the end and I kind of rushed through it. But the main thing I wanted you guys to have is the ability to figure out how you can tinker with this stuff on your own and kind of like dig into like what's actually happening. And it might take you reading a little bit more about numpy arrays and stuff. Real quick, we can do maybe what AB was asking is, so you can see this is the image in pixels. Let's see, where's the mask we made? We're running out of time, I know. Well, I can't remember like which is the thing that we actually want to show. Maybe I should just call it a day. But the idea is that whenever you want to check which what one of those masks will look like, let's say like if I wanted to see what this would look like, or if I wanted to see what the background would look like when it's been blurred. Oh, sorry, this is one more final thing. Whenever you're doing these numpy stuff, you have to make sure that they're the same size. So we have a handy function, resize. You can just use the existing shape, width and height. And I think that's right. It's in the documentation if not. So that's just a handy thing. But whenever you want to check what something looks like, you can do cb2.imshow and it will pop up in a window. It's a little trickier when you're in the Python interpreter because the other thing you need to do is like put it in a loop so that you could execute that wait key, but you can put it in an app.py just like how I have it written here. And then it will execute in sequence. If you're going to do it in the interpreter, you're going to need something like while true, show the window, if a key is entered, exit, because in the interpreter, things are just entered as soon as you hit the command enter. And then it will just show up a black window and it's annoying. You won't be able to see it. So, okay, sorry for the like delayed, kind of messy diatribe. I wanted to do a little bit more demos with you guys and now we're out of time. I hope that it wasn't too haphazard and you got something out of it. And you can always ping on Discord if you want.
Yeah, and this would be a great time for me to say, if you are interested in seeing the app, or seeing this app explained in detail, let me know. You can email me, you can comment on our YouTube channel, you can comment on this video, you can just comment on Zoom. Let me know and we can do a follow-up, and that way Lila has more time to kind of go through all of the nuances of the app. But Philip Ha did say that I tried both apps on my Linux PC and they worked fine. Yay. But he did say optimization can be done further for the virtual green screen. Thanks.
Yeah, so, well, please do. Yeah, and let us know how you do it. Yeah, for sure.
Maybe Philip Ha will come and do the second part of this.
Yeah, yeah, definitely.
Okay, so I just want to say thank you so much, Lila, again, for an amazing, informative Hacky Hour. It was a great demo. Very, very useful, and I think everyone really enjoyed it. No actual final announcements on my end, other than actually there is one announcement. We're hosting Hacky Hour for the next 2 weeks. They'll be focused specifically on model training. So if you're interested in learning how to train your own model and build an application using that model, join us next week. We're going to do a 2-part Hacky Hour. So it'll be the 10th and the 17th, I believe. So 10:30 a.m. just like last time. And join us, ask questions, let us know what you're working on, train some models, and we'll see you then. Okay, so yeah, Abis, you can reach out to us on Discord and we'll be able to get back to you then. Thank you so much for being a part of Hacky Hour and for being a part of this amazing alwaysAI community. And we will see you guys next week. Take care.
Thanks, guys. Bye.
Bye.